Welcome back. I hope you had a chance to practice some of your standard u-substitution problems. Let's take a look at one now that involves the next step in u-substitution, which is integration by parts. Here we go. So we're going to go e to the x sine x dx. Now what makes this problem a little tricky is that we have to do the u-substitution, and then we're actually going to solve this without ever really solving it. Let's see what I mean. How do I know what to let u equal? Lip it. Do we see a logarithm up there? No. Is there an inverse trig? No. How about a polynomial function? No. Exponential? Yes. And then trig would be the last choice. So in general, when we do a u-substitution, we don't want to let u be a trig function. By the way, that device was lipid. This is how we choose what we're going to let u equal in an integration by parts problem. Log, inverse trig, polynomial, exponential, trigonometric. Let's finish the problem. du e to the x dx. dv is sine x dx. What is the function whose derivative is sine x? That's right. Negative cosine x. What about the c? Don't worry about it. We'll take care of it later. Okay, so we happily go along the process. Integral e to the x sine x dx equals uv minus the integral of v du. v du. But I don't know how to do that. You're right, you don't. So what we're going to do is we're going to do integration by parts again. And if you think for a moment, we're going to end up with another one of these. We're going to be able to solve for it and then have our answer. So we're going to do the integral without ever doing the integral. Wow. I may need to take a break after this. Let's see how it works. Again, we solve the problem. Integral e to the x sine x dx equals negative e to the x cos x. Now, let's take a look at this one. Well, first of all, I know that's going to be plus e to the x cos x dx. I'm going to do integration by parts again. U equals e to the x dv cos x dx. So du e to the x dx, and then v, what is the function whose derivative is cosine? Sine. That's right. Now let's rewrite our problem. Here we go. Integral e to the x sine x dx equals negative e to the x cos x plus. Now, fortunately, this is a positive sign, so I don't have to worry about any distribution of negative values. uv minus the integral of v du. V du. But look what I have. E to the x sine x. Again. How about if I add this to this side of the equal sign and then divide by 2? I will then have an expression for e to the x sine x dx. And that's exactly what I'm going to do. So if I add this integral value here, that would become 2 e to the x sine x dx. I can combine these two, and I'm going to rewrite the order here just because I can, and then divide by 2. Oh, what about that c? Sure enough, there it is. Don't worry, it was there all the time. And that's going to be our solution. And again, feeling a little insecure? Take this derivative, use your product rules, distribute the negative sign, divide by 2, and you're going to get e to the x sine x. I promise. And here's a nice example of integration by parts. A little complicated, but you can see how it works. 99 times out of 100, when you do this first step of integration by parts, you're going to be able to evaluate that integral. And then it's all going to come out nicely. We chose this one for practice. Now, why don't you try a few on your own and check back for part 3. Thanks and have a great day.